Welcome to this deep dive into the world of software design patterns.
Yeah.
And get ready to learn about a real classic, the factory pattern. You've sent over some great resources, including Derek Banis's YouTube tutorial, and an article on the factory method from refactoring.guru.
These are fantastic resources to understand how the factory pattern solves common problems in object-oriented programming.
So it's like having blueprints for specific coding situations.
Exactly.
And the factory pattern is all about creating objects, those building blocks of software, but doing it in a way that keeps your code clean, flexible, and ready for changes down the road.
It's precisely that. You can imagine it like a real-world factory.
I like that.
You request a specific product, and the factory handles the complex details of putting it all together.
So we don't get bogged down in the how every time we need a new object. We just tell the factory what we need.
Exactly.
Okay.
Let's start with Derek Banis's video tutorial.
Okay.
He uses a video game example,
All right.
which really makes the point clear.
Yeah.
Imagine building a game
Okay.
with enemy ships that pop up on the screen.
Okay. Yeah, I'm with you.
Without the factory pattern, you'd have to write a lot of repetitive code every time a new enemy type appeared.
Okay. I can see how that would get messy fast.
Becomes a nightmare
Yeah,
to manage.
Lots of if statements.
Right.
And hard-coded object creation.
Yeah, especially as your game grows.
Yeah.
Yuck. Banis cleverly illustrates this with a random enemy generator.
Okay.
Let's say the generator picks UFO.
Okay.
That info goes to the factory.
Okay.
And boom, you get a fully formed UFO enemy ship ready to attack.
So the factory handles all those behind-the-scenes details.
It is.
Based on just that one input, UFO.
And that's the essence of the pattern. It encapsulates that object creation logic, separating it from the code that needs the object.
So it makes things more flexible.
Because what if you decide to add a new enemy type later on?
Right. Without the factory, you'd have to go back and change code all of your game.
Much cleaner.
But with the factory, you just update it in one place.
And much less risk of breaking things.
Much cleaner.
Yeah. Now, Banis also breaks down the core elements of the factory pattern.
Right.
You have your abstract enemy ship class, which defines common actions.
Okay.
All enemy ships can do.
So that's like the basic blueprint for any enemy ship in the game.
Then you have concrete enemy ship types, like UFO and rocket, which inherit those actions from the abstract class, but can also have their own unique behaviors.
And that's where things get interesting in the video.
The big UFO inherits everything.
Banis adds a big UFO enemy, which is a subclass of the regular UFO.
The regular UFO.
That shows how the factory pattern handles different levels of complexity.
But can also have unique attributes, like more powerful weapons.
Yeah.
And the beauty is the client code.
Okay.
The part of the game that requests the enemy doesn't need to know any of those specifics. It just asks for a big UFO. And the factory takes care of the rest.
So that keeps the game logic.
It does.
Really clean and easy to understand.
Yes.
Let's move on to the refactoring.guru article, which you said takes a broader view of the factory pattern.
This article focuses on the factory method, a specific flavor of the factory pattern, and it dives into the why behind it. It starts with the definition. Factory method provides an interface for creating objects in a superclass. But allows subclasses to alter the type of objects that will be created.
That's a bit of a mouthful.
Their example is perfect.
I'm glad they have a real-world example.
They describe a logistics management system.
To illustrate that definition, because frankly, my brain needs a picture right now. Designed initially only for trucks.
So they're shipping things.
Then the need arises to incorporate ships.
I see where this is going.
Without having to rewrite everything.
They need a way to create either trucks or our ships. Based on what the system needs at that moment.
And that's where the factory method shines. Instead of having rigid code that only creates trucks, they introduce an abstract transport interface.
So the transport interface acts like...
And then concrete truck and ship classes.
That blueprint defining common actions for any type of transportation. And then the specific truck and ship classes inherit those and add their own unique details.
And now the factory method comes in. It's basically a method within the transport class that says, hey, I need to create a transport object. Do I need a truck or a ship? It looks at the request.
and then decides which concrete class to use, creating either a truck object or a ship object.
Right.
So the system is now adaptable and can handle different types of transportation without a major code overhaul.
That's incredibly clever.
It is, and this adaptability is one of the key benefits of the factory pattern that the refactoring.guru article highlights. They talk about reducing coupling, which basically means making different parts of the code.
So instead of having code that's tightly interwoven and fragile, you have these more independent modules that can be changed or updated without causing a ripple effect throughout the whole system.
I've worked on projects where not thinking about coupling turned into a real headache later on.
That makes sense.
Even a small change became risky.
If everything is tightly coupled, one chain could break the whole system.
Because everything was so interconnected?
But with reduced coupling, you have more freedom to make changes and add features.
Exactly.
Without fear of unintended consequences.
And then they bring up the open-close principle. Open to extension. But closed to modification. This principle really resonated with me. It encourages designing systems that can be extended with new functionality.
So it's like building a house with a solid foundation.
That's a great analogy.
You can add new rooms and features.
And the factory pattern.
Without having to tear down the whole structure.
With its focus on abstract interfaces and concrete implementations really embodies this principle. Remember the transport interface. It defines the core functionality, but the specific implementation.
So if you need to add a new transport type...
Like truck and ship are separate.
Like airplane.
So if you need to add a new transport type like airplane, you just create a new class that implements the transport interface.
You're just extending the system.
Without touching the existing code.
Without messing with the core. And the article also mentions another benefit. Resource optimization.
They focus on database connections. But this applies more broadly.
It talks about reusing existing objects like database connections.
Think about game development.
Instead of creating new ones every time, which can save a lot of resources.
Let's say you have a game with hundreds of identical trees.
Oh, that makes sense.
Instead of creating each tree object from scratch.
So the factory isn't just about creating objects.
You could use a factory to create one tree object.
It's about managing them efficiently.
And then clone it hundreds of times.
And making sure you're not wasting resources by creating duplicates. Unnecessarily, it's about working smarter, not harder.
Exactly. We've got these two great resources. Banis's video with a hands-on coding example. And refactoring.guru's article with its broader conceptual approach. What stood out to you?
Well, Banis's approach is super practical. Like, he's right there coding with you. It's great for understanding the mechanics of the factory pattern, but refactoring.guru really helps you see the why.
I agree.
The big picture of why this pattern is so valuable.
Banis helps you build the house. And refactoring.guru helps you understand the architectural principles behind it.
They both contribute to a deeper understanding of the factory pattern. So for our listener who might not be a software engineer, why should they care about this pattern?
That's a key question.
How does it impact their everyday experience with software?
Well, they won't see the factory pattern directly. It's working behind the scenes to make the software they use more robust.
So it's like the engine of a car.
Exactly.
You don't see it, but it's what makes the whole thing run smoothly.
And both sources point out that the factory pattern can be a stepping stone to even more powerful patterns.
So we've covered the basics of the factory pattern.
It's like learning your first power chord on the guitar.
But there's more to explore. Where should our listener go from here?
The refactoring.guru article mentions a few related patterns.
What are those more advanced patterns?
Like the abstract factory and the builder pattern.
Let's dive into those.
The abstract factory pattern takes object creation to a whole new level. Imagine you're building a user interface for a software application that needs to run on different operating systems like Windows, Mac OS, and Linux. Each operating system has its own look and feel with different buttons.
So you need to create sets of UI elements.
Windows and scroll bars.
That are specific to each operating system. But you also want to make sure they're consistent.
That's where the abstract factory comes in.
Within each set.
It acts like a master factory. That produces families of related objects. Ensuring that all the elements within a family are compatible.
So you'd have a separate abstract factory for each operating system.
Great.
And each factory would be responsible for creating the correct set of UI elements.
The client code would just request
For that
a
set.
specific type of factory,
Okay.
like the Mac OS factory
Okay.
or the Windows factory, and then use that factory to create all the necessary UI elements.
It's all about managing complexity and maintaining consistency across different variations.
It is.
Okay, that makes sense for UI elements. But are there other real-world scenarios
Absolutely.
where you'd use an abstract factory?
Think about game development again.
Okay.
Let's say you're creating a fantasy game with different environments like forests, deserts, and mountains.
Right.
Each environment would have its own unique set of objects like trees, rocks, and creatures.
Okay.
An abstract factory could be used to create these sets
Okay.
of environment-specific objects.
Yeah, that's a great example.
Ensuring that everything looks and feels cohesive.
It helps me visualize how the abstract factory can be used to manage the creation of complex interrelated objects.
Now let's talk about
the builder pattern.
the builder pattern.
How does that differ from the factory pattern?
The builder pattern focuses on constructing complex objects,
Okay.
step by step.
All right.
It's like having a detailed construction plan
Okay.
that guides the assembly process.
Okay.
Think about building a pizza.
So instead of creating the entire pizza object at once,
You start with the dough, then add sauce cheese
you're building it up incrementally.
and various toppings.
Right.
Each step adds to the final product.
And what's the advantage of building an object this way?
The builder pattern allows you to do the same.
Why not just create it all at once?
With software objects,
Okay.
it provides a blueprint for creating an object
Right.
in stages, allowing for fine-grained control over each step of the process.
Okay.
The builder pattern shines when you need to create different representations of the same object.
Okay.
Going back to our pizza example,
Okay.
you can use the same basic building blocks.
All right.
Dough, sauce, cheese.
So the builder pattern allows you to create a variety of complex objects
To create countless variations.
using the same underlying structure.
You can have a vegetarian pizza, a meat lover's pizza, a gluten-free pizza, and so on.
Just by varying the steps in the construction process?
Exactly.
All right.
It's a powerful way to manage complexity and offer flexibility in object creation.
Okay.
Imagine a software application that generates reports.
Yeah.
You could use a builder pattern to create different types of reports.
Okay.
Summary reports, detailed reports, graphical reports,
These patterns sound incredibly powerful.
all of them using the same underlying data,
It's like having a set of specialized tools for building complex software systems.
but assembled in different ways.
And it's amazing to see how the principles we've learned about the factory pattern can be extended and applied
It's a testament to the elegance and power of design patterns.
in so many different ways.
They provide a framework for thinking about and solving common software design challenges.
So for our listener who's eager to delve deeper into this world of design patterns, where should they go from here?
In a structured and efficient way,
What resources
I'd highly recommend
would you recommend?
exploring the refactoring.guru website.
Okay.
They have in-depth articles on the abstract factory builder
Yeah?
and many other patterns.
Right.
Their explanations are clear and concise,
Okay.
and they often include real-world examples
Awesome.
and code snippets.
That's a great resource. And remember, learning design patterns is an ongoing journey.
Keep that curiosity alive.
As you encounter new challenges and explore new areas of software development,
Embrace the power of design patterns.
you'll continue to discover new patterns and techniques to add to your toolkit.
And never stop learning.
And on that note, we'll wrap up this deep dive into the world of the factory pattern and beyond. We hope you've enjoyed the journey and feel inspired to explore the fascinating world of software design patterns.